Hi there, friends. Welcome you all to my YouTube channel, Cloud with Mohsin. Friends, today we are going to discuss about a DevOps concept, that is Jenkins, and this is a popular DevOps platform. We are going to deep dive into Jenkins, its architecture, use cases, and lot of different things we are going to learn today. Before going to proceed with this session, friends, let me take a moment to introduce myself. I'm Mohsin Sheikh. I am two times AWS and two times Microsoft Azure certified professional with overall experience of 16 plus years in IT under various domains. Okay, so that was quickly about me. Now let's move to the index. Okay, so what we are going to learn today is, first of all, we'll see what is a CI/CD pipeline. Okay, you might have heard a lot of time about CI/CD pipeline, but we are going to see in detail what is a CI/CD pipeline stand for. Then we will understand what is Jenkins. After this, we will understand its key features and we will deep dive into its architecture. Following that, we will see how CI/CD pipeline works in with respect to Jenkins and what are the popular use cases. Finally, we will also discuss why we should go for Jenkins over the other available options, and we will summarize this session with whatever we discuss in today's topic. Okay, I hope the agenda is clear to you. Okay, now first thing first, what is a CI/CD pipeline? So a CI/CD, as the name stands, is continuous integration and continuous delivery or deployment. Okay, so in a nutshell, a CI/CD pipeline is a set of automated processes that helps developer deliver softwares quickly, reliably, and consistently. Okay, before a CI/CD pipeline, there was the concern from, especially from developers, that the integration and delivery is taking time. There's some dependency between the phases, and it was overall causing the delays in overall deliverables of the softwares. Okay, so CI/CD pipeline is a automated process that helps to take care of these concerns. So under key concepts, let's see what is a CI. So first of all, what's a continuous integration or CI? Developers frequently push code changes to a shared repository. So in the repository, if you are aware, you can say it's a GitHub or Bitbucket. There could be lot of repositories. It could be private repositories or public repositories. Okay, so developers frequently pushes the codes. So whenever developers are making changes to the code, they are pushing it to the shared repository. Okay, after this, automated builds and tests runs every time code is pushed. So you can make a kind of mechanism that whenever you are pushing the code, so it would build and test it. Okay, so here the goal is to catch bugs early and ensure code works as a unit. Okay, so simply continuous integration just focuses on catching bugs early and ensuring code is a complete. Okay, code is do not have any issues and it is perfect. Once CI part is done, that is continuous integration is done, next phase come as continuous delivery. Okay, so as it mentions, once CI succeeds, code is automatically prepared for releases. Manual approval may be needed before deploying to production. Ensures code is always in a deployable state. Okay, so here manual approval, so it depends. Maybe you might want to deliver it to the staging environment or production or development environment, so you can introduce some approval so that you can review it in the meanwhile before it is getting deployed to the specific environment. Say you want to ensure that before going to or deploying to production environment, you want to take a manual review. In that case, you could introduce a manual approval process here inside the inside the CD. Ensures code is always in a deployable state. So the aim or goal of CD is it ensures code is always in a complete or deployable state. uh, CD also stands for continuous delivery or continuous deployment as well. So this is the alternate name of CD. Okay, So this goes one step further and automatically deploys every successful change to production. Okay, ideal for teams that need rapid iteration and feedback. So in case of deployment, okay, it is especially suitable for the teams where you need rapid iteration and feedback. So it's one step ahead of continuous delivery. So a CI/CD pipeline is the this is, you can say, automated processes that mainly focuses and eases developers and ensures the developers are able to deliver software quickly, reliably, and consistently. Now moving ahead, let's see what are the some specific stages of the CI/CD pipeline. So stages are here. First is source. So what is the source? So developer commits code to version control like Git. Okay, so whenever you have a code, you are written in a code, maybe it could be in any language, say Java or Python or YAML. Okay, so wherever you are deploying, where you are committing the code in a repository, so that is called as source. So that would be your source. In this case, it would be in a source or Git repository. Build. What is the build stage? Build is a code is compiled and dependencies are installed. Okay, so in case of build, it ensures code is complete, there are no issues, dependencies are resolved, and that is taken care in the build. After build, it comes as test as a stage. The name as itself suggests, test phase is responsible for unit and integration tests which runs to verify functionalities. Okay, uh, after the testing phase is completed, then it comes deploy. So code is pushed to the staging or production environment. Okay, so as we were discussing in the previous stage, it depends where you want to push the code, whether you want to push it to the staging, that is non-production, or production environment. So this is taken care in the deploy. Under monitoring, that is next stage, systems are observed for performance and bugs. Okay, so this is a cycle, and this is a these are the some specific stages of a CI/CD pipeline. Now let's talk about the examples of each of these tools under which comes under as a part of CI/CD pipeline. CI/CD platforms, so Jenkins, GitHub Actions, GitLab CI. So these are some of these platforms which provides or enables as a CI/CD platform. For source control, where you could push keep your repositories, so Git is one of this example, as well as Bitbucket. Okay, build or test, so Maven is one of this tool. I'm sure that some of you might be aware, Maven, JUnit, Selenium. So these are the some of the build or test tools. Okay, for the deployment, we mainly use Docker, Kubernetes, Terraform, and AWS Code Deploy. AWS Code Deploy being a native technology or native service of the AWS. Apart from AWS Code Deploy, we have Docker, Kubernetes, and Terraform. These are all third party which helps to deploy the code. Okay, so mainly Terraform, I'm sure you might have seen my previous video. The Terraform is infrastructure as a code service that helps to deploy our resources to the cloud, and it's simple that we just need to work on the code in the Terraform format, and we used to push it to the cloud provider. Okay, so please watch this video so that you will understand what is Terraform. Okay, moving to next. Now let's focus hereafter about what is Jenkins. Okay, so Jenkins is an open source automation platform. It is used for building, testing, and deploying software, and it supports CI/CD pipelines to streamline development. Okay, as we had covered in the previous slide, Jenkins is one of the tools that helps us to get the CI/CD platform. Now here you can see a table below, and this table talks about key differences between traditional deployment and automated deployment using Jenkins. Okay, with respect to various aspects, first of all, let's talk about what is the setup time. So if we go for traditional deployment, setup time would used to take weeks or months. Okay, so You might be aware that whenever we used to work with the traditional deployment method, like we need to install a server, okay, so I'm talking about physical server, setting up network and all those things. It used to take weeks or months as well. But here, in case of DevOps or automated deployment, it just takes minutes to hours, because this is, very flexible and very easy to use and very simple to use, okay. So because of that, talking about the cost, traditional deployment would be costlier rather than as compared to the automated, that is DevOps deployment. Okay, DevOps deployment is costing us low. Scalability, in case of traditional deployment, it used to take, it, it needs external, requires external changes. So I will give another example with respect to server. Say for example, you are using a physical server and you want to scale it. So for example, you want to scale the memory of that physical server or disk. Okay, do you think it is as easy as scaling or doing the scaling up or vertical scaling in case of cloud? No, because you need to order the hardware, okay, you need to install it physically, then take the reboot of the machine and then restart. So it's not easy to perform the scalability with respect to traditional deployment, whereas in case of DevOps deployment or automated, it's automated and on demand. We can go on demand in case of that. So similar to that, talking about control as a aspect, with traditional deployment we have limited control, and automated deployment gives us the self-service, so we have a better control here. Flexibility is low and high in case of DevOps or deployment. Automation, obviously, because of some dependency on the external factors, there is minimum automation opportunities with respect to traditional deployment, and automated deployment has better or extensive automation capabilities. Okay, time to market is slow, so this is the main thing. So when we go for the previous or as is methods of deployment, so time to market was lower because there was dependency on many of the things and it used to stuck. But with respect to the newer approach or latest approach, it has accelerated deployment. A most important thing here I wanted to focus is developer focus. So the way we used to work in earlier without using the DevOps tools like Jenkins, etc., so it wasn't at all focused on developer, okay. But these tools, Jenkins, the tools like Jenkins are mainly focused on developers, okay. They are here to set up or ease or facilitate the developers with their work, okay, so that the developers can focus on the code rather than worrying about infrastructure or the backend things, okay. So that is the main thing here. Now, what are the key features of Jenkins? So Jenkins is extensible with more than 1800 plus plugins. You can say extra features, or it integrates, it helps us to integrate with different service providers. Supports multiple platforms and languages, so you name it and all those languages are supported by Jenkins, okay. It integrates easily with Git, Docker, Maven, etc., as well as Terraform as well, so you can easily integrate. You just need to install the required plugin and you can integrate with the third party or other tools. And triggers builds automatically, so you can either commit or you can schedule the builds, okay. So no need to do it manually. It can help us to, we can set up the pipeline accordingly and triggers are built automatically. So these are the some of the key features of Jenkins. Now the important thing is here. Now let's understand what is the architecture of Jenkins. So see, it's very straightforward architecture. It is a master agent or master slave architecture, you can say. We have master, so master is the main server where you have Jenkins installed, and it is mainly going to take care about the scheduling and monitoring of the jobs. You can also call this as a controller. While agents could be, there could be many agents. Here you can see in this diagram we have 3 agents: production server, for deployment server, and one for testing server, and each of the agent executes builds on different environment. Production server would be able to build execute the build on production server. Similarly, development and testing can do. Okay, so this is a very simple architecture of Jenkins. In some of that setups, it's not needed that there are two separate machine for master as well as slave. Suppose you have a very small setup, you can make the same machine to work as master as well as slave. Okay, again I have seen many of the examples where the agents are automatic. So agents are something that when you are using on demand EC2 instances, you can run the agents for 30 minutes, and if there is no next job available in the queue, you can just, the agent gets terminated itself, and whenever the next time another job is in queue, it launches the relaunches. So you can have some auto scaling group there, so that you can build or save some cost with respect to this approach. Okay, so that is quickly about this Jenkins master slave architecture. Okay, about talking about CI/CD pipeline, as we have seen covered the several stages. Here you can see in the CI/CD pipeline of Jenkins, we have commit, build, test, stage, and deploy. Okay, stage here is additional things, or you can say optional thing. Here you can say, here you can mainly uh, configure if you want to have some approval, manual approval for deploying onto staging or production or QA, etc. With respect to that, you can set up on some staging here. Okay, here you can say from development to production. Okay, we have code commit, git as the repository, so you are pushing your code via code commit, the AWS service or some other tools to your git or bitbucket repository. From bitbucket or git repository, you have integrated it with Jenkins. Jenkins will take care of that. It will execute and push it back. Okay, so if say there are any issues with respect to source, that is our code, it will push back. We can rework onto that. If there are no issues, once our commit is successful and all the relevant stages are completed, then it would be pushed to the production environment. So this is simple terms to explain about the CI/CD pipeline. Okay, now understanding some popular use cases. Okay, so here I have listed some of those use cases where Jenkins is mainly used. First, in continuous integration for teams, then automated testing for faster feedback, deployment to production or staging servers, integration with cloud server providers such as AWS, Azure, etc. These are some of the popular use cases where we are heavily using Jenkins. Now you might have question, okay, why we should go for Jenkins? So for choosing Jenkins, we have different answers why we should go for it. First is, it has large open source community. It is free and customizable. Okay, it is proven reliability. It has proven reliability for teams of all sizes. So Jenkins is very popular tool. So you can use it. You can customize it as per your requirement. It's free of cost. Only you need to set up some EC2 instance or etc. And on top of that, you can install Jenkins if you are going for server based architecture. So you can do that. Now friends, we are at the end of this session. Okay, now let's quickly summarize whatever we discussed as part of our today Jenkins session. So what we understood, CI/CD pipeline is a set of automated processes. So mainly it helps developers to deliver software quickly, rapidly and consistently. Here CI stands for continuous integration and CD is continuous delivery or continuous deployment. Okay, stages, in a typical stages of CI/CD pipeline comprises of source, where you are a source such as git or bitbucket. Okay, build, in case of build, if there are any dependencies, gets resolved. Under testing, you are taking care of manual or your relevant testing to test the functionality of the code. After testing is done, you will deploy it either on staging or production environment, and you will monitor this to observe if there are any issues so that you can work on it. Okay. We discuss about Jenkins. So what is Jenkins is it's an open source automation platform. It is mainly used for building, testing and deploying software. Okay. It supports CI/CD pipelines to streamline development. The architecture is very simple. It has master slave or master agent architecture where master is mainly taking care of, you can say master is the brain of the architecture. It schedules and monitors the job, whereas agents just takes care of executing of the jobs builds on the different environment. So there could be the scenarios where we don't need a separate master and separate slave. Only one machine can take care of both of the things, but depending upon your workload you could customize and you can have multiple agents or slave machines based on your use cases. Okay, some of the popular use cases that we discussed about in today's session are continuous integration for teams, automated testing for and feedback, deployment to production or staging servers, and integration with cloud service providers such as AWS, Azure, etc. So these were some of these popular use cases. So friends, that's it for today. We will try to have a hands-on of the Jenkins lab in the upcoming session based on availability. Okay, so that's it for today, friends. I hope you understood the concept of Jenkins. It is a popular DevOps tool, and it is mainly being used in most of the setups these days because of its ease, free of usability, and some other important features. And it's very easy to integrate with other cloud providers as well as some different tools like Terraform, Docker, Kubernetes, etc. Okay, thanks for watching this video, friends. Please don't forget to like, share, comment and subscribe to my official YouTube channel. This is Cloud with Mohsin. If you have any question, just feel free to write in the comment section. Okay, thank you so much for being with me and take care. Bye bye.